Good morning everyone, welcome to the homework portal. This is the last problem of the series, so which will be published on 27th September. Okay, so this question is for 10 marks, so I have allotted a time of 10 minutes to solve this problem. Let us see whether we are able to do it. If you are able to solve problems within that stipulated time, you will definitely able to do well in your final exams also. So see to it that, okay, without seeing this, since you already have the hard copies of this one, try to solve it yourself. And still if you are not able to do, okay, so extend your time. Okay, now let us start with this. Start the timer, right. An object is, this is a problem on data analysis. An object is rolled from rest down an inclined plane, okay. The distance traveled by the object was measured 7 different times. A graph was constructed for the distance traveled against a time taken square. This is t square as shown below, okay. This is distance traveled by time taken square. So there are some error bars shown here. These are the central points that have been marked. Appears to be a straight line passing through it, right? Okay. So which means at t equal to 0, it can touch somewhere over here, which is around 1.2 centimeters somewhere. It's not passing through the origin. So if definitely, if there is a question on saying, is it proportional? You should say no. Why no? Because it does not pass through the origin. Okay. So even before looking into the question, we can very clearly ascertain that what kind of questions can come here. Right. So now, what quantity is given by the gradient of the graph? So we need to look into it. How many questions? 2 marks over here. Okay. Gradient of the graph. Now you see, this tells you the gradient of the graph. So if I draw a graph over here, sorry, a line over here, so it should pass through all the error bars, and he has already given the situation. Okay, it says it's rolled around from rest, which means what? Initial velocity is 0. So therefore, so this corresponds to something like your equation s equal to ut plus half at square. Now if t is equal to 0, this becomes 0 plus half at square, and then we can have, is the angle of the incline given? Angle of the incline is not given. Okay, so therefore what is s? S is along the y-axis, and this t square is along the x-axis. This half a is along the, is the slope. So this is your mx. So what is the slope? Slope is nothing but a by 2. A by 2 is nothing but the slope. Okay, so what should you write? This is for 2 marks over here. So first what you do is, you write s equal to half at square is derived by putting u equal to 0 in equation s equal to ut plus half at square, so that this becomes half at square. Identifying y is equal to s and t square is equal to x. We have y is equal to capital M into x, okay, plus c, y equal to capital mx, actually here not even plus c, so according to this equation. So therefore where m is equal to slope, which is equal to a by 2. That's it. Okay, you can write this one here. Then explain why the graph suggests that the collected data is valid but includes a systematic error. Why is there a systematic error? See, what should happen ideally? At time t equal to 0, the particle should have been at the value of s, right? But what has been happened? So you see here, at time t equal to 0, s should also be 0. Is s 0 here? S is not 0, which means s is at some point over here. There is a systematic error. There is a systematic error which has been seen over here. Now this systematic error, how do you identify this? See, if suppose if the same experiment was conducted by removing this error, then you should get a line parallel to this original line. Okay, that's the idea. So how do we get it? Now what you do is, if you take a scale and then you draw this one here, do I have a scale here? Let me check it out. Whether do I have a scale? I don't have a scale here, I think. I don't have a scale here. I will not be able to do that here. No, where I have. Okay, so let me draw it approximately. Don't say I have biased it. Okay, so if I draw it here, almost these two lines are seen to be parallel, and this line is seen to be passing through the principal axis. So the what do you call, the parallel axis over here. Okay, see, I have done the same problem in my paper using a scale, as you can observe here. So I have got it exactly parallel over here, right? So this is what I do. So before I solve the paper, I actually try it out in my graph and see whether it works or not, and then once I get the correct solution, I look into it and then I do it over here. Okay, so therefore you see that these two lines are parallel. That means the error that you observe at the origin, the same error is being observed everywhere. So this is nothing but a source of the systematic error. Thus, there is a systematic error. Explain why the graph suggests that the collected data is valid but includes a systematic error. Why? Because the collected data gives you something like y is equal to mx plus c, where c is the intercept which is being found, but this should be a source of systematic error, and this error, systematic error, and this error is observed in all data points, hence, okay, it includes a systematic error. You can mention this. Okay, so here beginning itself don't mention systematic error, you just mention it as error. Since this error, now you write this something like since this error, see, it should be this statement is what you have observed, and finally there should be a conclusion. Okay, in all data points, this error is a systematic error. This is how you should write. Okay, so you get 2 marks over here. Now let us look at the next one. Do these results suggest the distance is proportional to times taken square? I already told you it is not, right? Because if it is proportional, when you use the term proportional, what should you say? So the line has to pass through the origin. Does it pass through it? No. Okay, so you can say no, it is not proportional because the line has to pass through the origin and is not observed in this graph. You can mention this, right? So this is done. Then making allowance for systematic error, calculate the acceleration of the object. What is the acceleration of the object? Simple. Okay, so now what we need to do is go back here and find out what is the slope here. So what is the slope? Let us take up 2 points over here. How do I take the 2 points over here? I can take anywhere over here, but as much as possible, let me take points where this crosses will coincide. I take 1 point here on this line, and I will take another point here on this line. Which is this point over here? This point is something like 3.6 over here. Okay, so 3.6 is here, and what is this point here? This point here is 0. This is 0.15, and if I take once again, if I take it here in between these 2 lines, this is 0.123, 0.13, 0.14. It lies between 0.13 to 0.14, first point. Okay, which point is this? We have taken this point. Now let me take up the slope here. Let me take up some other point. All these points are farther away. Okay, let me take up this point over here. Okay, so here, what is this value here? This value is 5.2, 5.4, 5.6, 5.6, and what is this value? This is 3 over here. Now let us write the slope. Slope is equal to 5.6 minus 3. What is this? In centimeter, divided by, what is this value here? 0.2, 0.25, 0.25 minus 0.25 minus, what is this value? Either 0.13 or 0.14. Are we taking it correctly? No, this is not the one. We need to look at here, right? This is the point. This is the point we need to look at. We made a mistake here. So therefore, this point would be, hey, then this would be 3, correct? Yeah, this is 3 here. That's right. Okay, this is 3, and this value would be, what is this? 0.1. 0.1. Okay, now let us do the math. 5.6 minus 3. Here is my calculator. 5.6 minus 3. 5.6 minus 3 is equal to so much, 2.6. So 2.6 divided by 0.25 minus 0.1 is 0.15. What is that we have got? This is nothing but s by t square. Okay, which we said that this is equal to a by 2, right? Now let us find what is 2.6 divided by 0.15 will give you 17.33. This would be 17.3. So a should be equal to 17.3 multiplied by 2, which should be around 34.6. 34.6 meter per second square. It's too much, man. 34.6 meter per second square is too much. But what is that we are missing? We're missing something here. Maybe the unit. See, what is this here? This is in centimeter. So this should also be in centimeter, right? So if this is in centimeter, then I should write the value of A should be equal to 0.35 meter per second square. 0.35 meter per second square, or if I want in one single significant figures, I'll write this as 0.4 meter per second square. Now the marking scheme also says you accept anything between 0.35 to 0.4. So you got it correctly. Okay. So therefore this answer is also answered. This is 0.4 meter per second square. Okay, so we have answered the fourth part also. Now let us look at the last part of this question. The following graph shows that the same data after the uncertainty ranges have been calculated and drawn as error bars. See, these are the error bars. See, this is the error bar here, right? So similarly, we have error bars. Not so clear, but we can make it out. Okay, distance traveled in centimeter versus t square is given. Add two lines to show the range of the possible acceptance values of the gradient of the graph. So what you need to do is take the least point, okay, in this, and take the maximum point here, okay, and in between them draw a line such that it should pass through all these points, all this within these ranges. So now I'm going to draw here. So it's already right, it's almost this one. This is one line. Then similarly draw one more line. This is one more line. So take up the maximum uncertainty here, take up the minimum uncertainty here. Between these two, draw a line. It would look like this. It look like this over here. Here, take a scale and do it. You will get it correctly. So then, what does it reveal is that this will give you one slope m1. This will give you the another slope m2. We call this as a lines of. We call this as lines of worst fit. Worst fit, which means what? You can have the gradient between m1 and m2. Okay, if I draw a line properly, see, if I draw a line here joining the central points, I may draw a line like this over here, passing through the valley of these two. This line that I have drawn now, this is called as the line of best fit. This is called as a line of the best fit. We call it as LOBF. This is called as a line of worst fit, WF. Okay, line of worst fit. That means your slopes can lie between this m1 and m2, and the maximum uncertainty in the gradient is, if I take m1 and m2 here, this should be m1 minus m2 divided by 2. Okay, so I think this is the end for this question. I hope you have understood a bit of data analysis. You would be able to solve any problem in data analysis. Let us see, like, if you have any more questions, you can always ask me in the classroom, or maybe you can put across in the comments. I'll be happy to help you out. So shortly I'll be starting a community in my Telegram group or in WhatsApp group. We have to decide about it, and then we can have courses on it. Okay, thank you everyone for patiently watching this. So be in touch, do like, subscribe and comment to my channel, so that it'll be more helpful and it'll motivate me a lot to do more number of videos like this. So in fact, you can also specify what topics you need. Any topic which is very difficult, you can put it across, so definitely I can help you out with it. Okay, thank you very much.